So last week, we demonstrated how this paper was implemented. So where we show to us practically in Weka, so that we cannot take clue. From how can we also replicate in our own different area of specialization. So we took us through the two algorithms that were implemented in this world, support vector machine and the D48, which is a type of decision tree. Looking into it in detail, we demonstrated how to bring in the data and also carry out the experiment. So today, we are going to hopefully conclude this series on especially on this anxiety paper. We're going to look into the paper itself and see what can we take from it, what benefit can we take, and then how are the experimental results put together to form what finally culminated in the actual paper. So here is a free for all paper in the sense that it's an open access paper. So you can just Google it, you can search and download it. It's available for free. Anybody can download it. And I want us to pay attention to a couple of stuff that when you're writing paper based on machine learning experiments, some of the very important points we need to face. So we are going to look into the full paper today, so to see how it has been written and how we can actually pick up our own data in our own field or our own area of interest and also replicate and produce reasonable published work. Like we said, this is in this Journal of Informatics in Medicine Unlocked. The prediction is a Scopus journal, a prediction of generalized anxiety levels during COVID-19 pandemic in machine learning-based modeling approach. So the first and most important stuff, if we look at our previous videos on how to write research paper from machine learning experiments or based on machine learning experiments, abstract, just like any other paper, is very important. See, however, we give us a few guidelines, especially from machine learning point of view, what are very important things that we need to focus on. So, and I give us what, why, and how, which means what you want to do. You have to paraphrase in a very simple form because abstract is usually fewer in number of words allowed, but as fewer as it is, we have to make it comprehensive. That it covers what you want to do, why you are doing it. The why you are doing it, we say it has to be covered from 2 points of view. Why the research, the importance of the research. That's the first part of why. The importance of it, you have to make it very clear, as it has been clearly stated here in this work. The second thing is why is this work still needed? Sometimes the work is important. However, someone already did it. So why do you need to repeat it? That is why the why from the point of view of literature cover is very important. What you want to do, that's very clear. The second thing is why. Why are you doing it? You can tell us why it is important. Why anxiety is very important to be detected earlier before it snowballs into depression and finally anything could happen. These are the important, why it is important to investigate this kind of work. However, maybe someone did it before. This is why where literature review will come in. So you must be able to state in the abstract why it is still needed. Although it is important, however, someone did it last year, or someone did it last month, or someone already did in the literature. So why are you doing it again? So that's why we must be able to have literature review that will establish the need for this particular work. So this is what I usually call the second part of why. The why of the importance and the why of the gap from the literature. Is there any gap? Can you get any gap in the literature? After that is how. How do you want to solve this problem? You tell us how you want to solve it. Okay, we want to use machine learning, specifically support vector machine and decision tree. Then why? Why machine learning? And then why support vector machine? There are so many algorithms. Why are you selecting these two? You have to tell us, because support vector machine is well known to be able to work when the data set is few. It has demonstrated successful application in several areas of medical work. J48 is very easier to be explained to non-experts in this area of machine learning because of its tree representation or diagrammatical representation formats. So you try to establish the need for your work and then how you want to do it. So once you are able to tell us the how, that is the method you want to use or the algorithms, and then the need for that algorithm or the justification for it, then your abstract is almost ready. Finally, you need to tell us the summary of the results. Tell us, what did you achieve? Because before you write the paper or you write the abstract, it is assumed that your work is ready. So you have to tell us, for example, experimental result demonstrated promising result for the early classification of 2-class and 3-class anxiety problem. See, as for comparing support vector machine and J48, the SVM outperformed the J48 by attaining a classification accuracy of 100%, precision of 1.0. So you tell us a little bit of summary of the results. However, there's no space to tell us more, but this basic information needs to be there. Next is your introduction. See, I really encourage us to pick up the paper and read it on our own. So the introduction will repeat basically the same thing I mentioned in abstract, but in more detailed format. You need to tell us what you want to do, then why are you doing it? Why from the importance level, that is, tell us how important is this, why we need to quickly detect anxiety so that we can prevent people slipping into depression, and so many other advantages or importance of it. However, we need to mention what are the literature. Has anybody done it before? But this is introduction. The more the citation in your introduction, the better, by the way. Unlike abstract, where it is not allowed. It is not allowed to have citation here. But here, the more citation you have in your introduction, the better, because it gives the reviewer the impression that, oh, for you to have all this kind of relevant citation, you are well aware of what you are doing. You are well read in this area. You have studied the literature. You need to tell us what has been done that is closer or far away from your work, and then use it to justify why your work is still needed. You have the gap. This has to be very clear from the introduction, because here you have to put as many citations as possible. Although people work on this area before, however, no one ever worked in Saudi Arabia data, and no one worked on COVID-19 data from Saudi Arabia. Give us things that can justify that this work is still very much needed. So all this we can find appropriately here. After that, you move to the how, the what, why, and how. Then how you want to solve the problem, where you're going to mention. This is due to the arrangement of the paper by the publisher. This is the literature survey. We'll come back to that later. You see, so we try to introduce AI machine learning. We say in recent years, there has been an increasing interest in using machine learning models in predicting anxiety disorder. You see, we try to establish that, okay, the interest of reason, tell us what has been done. How is this new work different from what has been reported in literature? This must be made very, very clear, and it's very, very important. So once you're able to establish that, tell us what you want to use, what is the algorithm you want to use, and tell us the reason why you want to use these particular algorithms. So this is very, very important. So in introduction, you can cite as many as possible. You can say that support vector machine has been reported with successful applications in different areas of medicine. For example, cite some published work to support what you are saying. In abstract, you don't have the opportunity, but in introduction, you have the opportunity to cite as much as possible, because the introduction is an extended abstract, by the way. The same thing abstract, but now you are saying it in more detailed format, supported with necessary citation. And like I said, the more the citation, the better, so that you can really convince benefit the reader, while you're able to convince the reviewer and the editor that, yeah, you are aware of what you are writing, because this is very important. The moment you write, you read an introduction to a paper, no citation, then what is the evidence? What is supporting this author that we can really believe in what he's trying to do? Because we cannot see authority. Because citing earlier work means that you are aware of what has been done, which means people need to pay attention to your own work, because you cannot have a gap without necessary literature survey. So this is introduction. Of course, the next thing is you need to also describe your result. In the introduction, again, you have to summarize your result. In fact, you have the opportunity to summarize it more. You can dedicate a whole paragraph under your introduction to summarizing your result and telling us the implication of these results. What is the implication of the result you have gotten? How is it going to impact the area you have worked, the medical community, the patient, and the community or the country that sponsored the project? So you need to tell us the implication of your work towards the end of the introduction. This is very important. So this is what I call what, why, and how, and then summary of your results and the implication of the results. To me, these four things need to be appropriately positioned when you write paper from machine learning experiment. So, in the result, because machine learning experiment mostly deals with comparison. You want to compare your work with another algorithm. The two of them are just being used for the first time. Okay, this one is better. Why do you think it's better? We have discussion of result later where you can make it more detailed. But at least the short summary has to be there. Sometimes you have people already work in this area, even the same data set. However, they achieve maximum of 80% or 85% accuracy, even 92 or 93% accuracy. Definitely there's need for someone else to work and make it better. Once you are done with your introduction, well written, then you move to the literature survey. Of course, you must have done your literature survey clearly before you can write a very powerful introduction, because in the introduction, you need to refer to your literature to justify the why. That is the why, what is the need from literature point of view for this particular work of yours. So in the literature survey, of course, has been done appropriately. However, I would like to show you this table that we saw earlier. Look at this table. Very nice table. It's not compulsory, but it's very good if you have table to actually summarize, to pinpoint what are very important stuff from your findings. You can see here, this is overview of review sources arranged by date of publication. You can see here author citation, title of the article or chapter, maybe it's a chapter in the book. See, modeling anxiety and fear of COVID-19 using machine learning in a sample of Chinese adults. You see, what is the objective? State the objective here. That is why they did the experiment. What was the aim and objective? What method used? Tell us the method used. You can see in a summarized form. Of course, you have done a detailed review below in the system, but this is very easier for even the reader to appreciate what you have done, and also the reviewer. They like it because it makes life easy for them. At a glance, they can see this. They can see the gap. This is the findings of this research. The research actually established these findings. However, these are limitations that our team detected. Here, limitation for this data was from one geographical area in China. They only included self-report measure of psychopathology. So even anyone who want to still work in this area, mere looking at this limitation will be able to know, okay, where can I go next time when I'm trying to see what to work on? So this is one of the advantages of this kind of tabular presentation of our literature survey. Although it's not compulsory, like I said, but it's usually, it adds some values to your work by way of making it easier at a glance for people to understand what you have done or to understand the gaps that have been noticed in literature. Once we are done with that, we are moving to the real machine learning area now, which is the section 3.0, description of the proposed techniques. See, the proposed techniques need to be described as summarized as possible. So mention important things. You can always refer the reader to the actual source of the method. For example, support vector machine, it's not a new method, but you are using it on a new environment, in a particular totally new study, which is fine, which is excellent, by the way. However, tell us a little bit of support vector machine. So tell us a little summary of how does it work, what is it, how does it work, support it with some equations. That's why I said people who need mathematicians. So you might need equations to explain how it works, what is the mathematical background. And please, when you try to describe the mathematical background of algorithms, Don't copy paste images. It's really very bad practice. Don't copy paste the image. You have to type it out yourself. Although you are taking it from another source, because you are not the owner of support vector machine. You didn't develop it. That's fine. You see? So look at it and try to type out the equation. Of course, you make citation to the source. However, this is where the effort of mathematicians are needed. Sometimes mathematician knows the way to, because you have to avoid plagiarism while you are writing these equations out as much as possible. This is why I say you need to seek mathematician support. Mathematician will look at this equation, and will know how to rewrite the same equation without changing anything, but in a different manner. You see? So this is done, and this is actually encouraged to avoid plagiarism, because plagiarism software, we catch it out to cut this equation is matching this equation. Can you rewrite it in another way? You are saying the same thing, but actually in another way, in another form. This is highly encouraged. So, because mathematical presentation of the method is very important. So you can collaborate with a mathematician who will undo the mathematical aspect of the description. You might even introduce something that are missing from the previous publication, try to make it clearer to people how it works actually. And then this is what we describe, summary of it in the videos that we uploaded of recent on support vector machine. A very, very interesting classifier with unique capabilities that we've explained in that particular 3 videos. The second one is the J48, which is a type of decision tree. You also see a little bit of description, not up to 1 page, just short description, but you make reference to sources where people can read more. In fact, you can say that for further detail about this method, you can refer either to some important sources that you think provided better explanation of this method, because your paper is not the place to produce full description of this method. It's not your job. Anybody can easily see it over there. However, you want to be able to explain little things, especially how you are able to link it with the work that you have done. You see how many attributes did you have? How many of these attributes are necessary? How many of them are entering the system and coming out finally? And after that, you have your empirical studies. This is basically where the machine learning experiment starts. So the empirical section 4.0. So you have the empirical studies, which is starting with the description of your data set. Here you have to tell us about your data set. How many attributes? How many targets? Is only one target? Is it classification? Is it regression? You have to make it clear in your description, especially if you are the one that generate the data like this one. This data were collected by our team, so everything made very clear. However, if you take if you took the data from online source, it's compulsory for you to mention the source. Like I said, people must be able to reproduce your research. You don't hide anything there. But if the data is confidential, sometimes data from companies, they say it's confidential, you cannot release it to people, but still you make it very clear. We got it from so company ABC. Sometimes they ask you not to mention their name. That's fine. We got it from a particular company from so Middle East country or whatever, or from an African country. But it must not be left totally vague. Let it be clear. But for more detail about the data, the author, anybody interested can contact the author. That's why you have corresponding author in the paper. They will contact you. Sometimes you might be able to give them in confidence. Sometimes the data is not yet available. Maybe after a few years, some company will tell you, if you work with our data, you do mention our name, and you cannot release the data to the public until after a few years. Some of these companies, they mention that because of competition. They don't want competition with their competitors. They don't want them to know their data or the secret of their data. But if you are not in this category, please provide as much details as possible. So where you got the data is very important if it is an online data. And by the way, you can get data from online and make a very, very powerful paper from it, powerful publication from it. Either it has been used before, but you want to improve the performance, or it has not even been used before, but it's a very good data that you think is solving a real-life problem. So these are the variables. Describe what are the attributes that are important, that are in your data set. You can see So you can see here Q3, nationality, you have the gender, the age, marital status, and also for other questions. You see, so on that, we are still under the description of data set. We also did correlation between each attribute and in the first experiment, target attribute. That is, we had two problems we solved in this paper, as I mentioned earlier. We predicted anxiety or no anxiety. The second one, low, medium, and then low, medium, and then high anxiety. 3 classes. One is 2 class, the other one is three classes. Now, so for the 2 class, you try to do correlation. Correlation is the very simple correlation you can do in Excel. You can also do it in Weka, by the way. It's trying to correlate each of the attributes to the target to see which of them is very important, which of them is contributing more. You can see here, question 31, look at it. Not being able to stop or control worrying. You can see here that it makes a lot of sense. That somebody who is suffering from anxiety might not be able to stop or control being worried. 0.69 correlation. You can see we arrange it in order to the extent that some are really having 0.00. It means their correlation is very low. And when we are going to do feature selection, you will see that some of those attributes will be kicked out. They are not very important. The lower the correlation, the less important those attributes are. You can even see here, nationality, Q3, is very low, 0.02. Of course, still higher than others. So it shows that anything with 0.00, it means they are very, very low correlate. They are very low. They have very low correlation to the target. We did also for the second experiment, which is 3 classes. You can see the 3 categories. The almost similar pattern of correlation are done. All these are done under description of your data set. And also we call something statistical analysis of the data. Try to do it. See? So describe your data. What's the minimum of Q1? What is the mean, the average, return values, the median, the standard deviation, the maximum, the minimum. Sometimes when we look at the minimum and maximum, we look at this simple table, it communicates a lot. If the maximum is 2, minimum, this is okay, it looks good. 30, 0, that's okay. But if I have maybe 2 million here, maximum is 2 million, and then minimum is 0. Where is this gap? This is how sometimes by looking at your statistical analysis, I can detect that there is an outlier in your data, and I can advise you accordingly. You see, this is why it's very good to start with this statistical analysis of your data, because if the maximum is so big and the minimum is so small, maybe something went wrong. Somebody wanted to type 200, and then he ended up typing 2 million. So by the time you look at this particular simple statistical analysis, you might be able to think, oh, maybe something is wrong with my data. Because remember that let the data speak. If your data coming in is very bad, then you might not be able to get reasonable results. So by having statistical analysis, the reviewer will look at your data. Okay, seems the data is in order. Some of them will pinpoint, they will detect something. No, something is wrong with your data. You cannot get this kind of result you are reporting based on the data you provided. That's why everything needs to be as accurate as possible. Now, having described your data, and don't forget to tell us where you got your data from. The next is experimental setup. Experimental setup. Statistical analysis, we have discussed that. Experimental setup. This is where you describe your experiment. This experiment was carried out using open source software called Weka that afford machine learning algorithm to build an anxiety prediction model. You see, you describe what you have done. In the description of an experimental setup, the secret is this. Tell us everything that you know that. If you don't tell us, there's no way we can know it. This is the summary. Any information that if you don't tell us here in this section, there's no way we can know what you have done. It becomes compulsory to tell us what you have done. For example, how did you partition your data? Is it 80% training, 20% testing, or you use 10-fold cross validation? Because if you don't tell us, there's no way we can know. Don't start telling us how to load Weka, how to install Weka. That's not your job in this paper. You see, anybody want to load Weka, we read online how to install Weka. However, there are information, there are some things you have done in your experiment that if you don't tell us, there's no way we can know. Those are very important information that must appear in your experimental setup. We have seen in the past where people, one of my students published, was reading literature, preparing literature review, and they found a paper that got published in one journal. The paper didn't mention the percentage split, how they split the data. Is it 80%? Is it tenfold validation? I said, no. Send me the paper. He sent the paper, and I found out everything is missing. Then I had to see. And I found out that it was from one of these junk journals, predatory journals, journal that would just accept your paper by collecting money, but they will never read what you have done. But this is very simple, very important. If I compulsory, if you don't tell us the percentage split of your data in the machine learning experiment, then how can we repeat the experiment? Because one of the essence of reviewing is to make sure that this result you are claiming can be reproduced. So if the percentage split is missing, definitely there's no way anyone can reproduce your work. So this is why these are some of the things you have to tell us in the experimental setup. Tell us the method you have used. You can see here we made it very clear. We use tenfold cross-validation. Very clear. It must not be missed. So that is experimental setup. People do ask me, what do we put in experimental setup? And I summarize for them. Anything you have done that if you don't write it, there's no way people will know about it, because that experimental part will be lost. It's compulsory, you have to put it there. But things that you have done that people can easily know online how to do it, you don't need to tell us how you have run Weka, how you need to load this or load that. It's not your business telling us that. Now, the next is performance measure. Tell us how you are going to measure the performance of your experiment. You see, what are you going to use? How are you going to determine if your model is good or not? So like accuracy, precision, recall, F-measure. Usually you select based on what people have used in the literature. If you are comparing your work with another earlier work, you must use the same quality measure. Except if you have seen that they miss something very important, then you need to add it to your own, but you have to make it clear, because you can't compare that particular parameter that is missing in their own paper, you can't compare with your own, but you can mention it there. However, you have to include as much as possible of what they have used, because their own paper is like the basis for you to compare your work appropriately. So you mentioned this, you can also give a little description of them if necessary. So, because these are things that you are going to use to judge your experiment. The next is optimization strategy. We described this practically last time. You see, optimization strategy is very important. So there are different ways of doing optimization, but the simple one is the systematic one, whereby you are going to fix one, use all the default value and start changing them one by one. For example, support vector machine, you start changing the kernel function. You try polynomial, you try Gaussian, then you try all them other kernel method function that are available, and then you select the one that gives you the best result. Then you fix that best one, and then you keep changing the other parameters. This is what has been done, I think, here. You can see there are a couple of plots. You can see the kernel function, the search for the polynomial kernel, normalized, PUK, RBF, and they finally settle for polynomial because it gave them the best. They search for cost. They also got the best. This is what we call optimization. It's very, very important. You have to optimize your algorithm. At least you want to get the best hyperparameter values that will give them the best result. If you optimize one algorithm and you don't optimize the second one, it is an invalid experiment because you are subjecting them to different scenarios. So you have to give them their own benefit to select the best parameter so that you can compare fairly. Now, so after the optimization strategy, then the full-fledged experiment starts. So you report your results. See, give us your results as the case may be. So then there we call result and discussion. This way you start discussing your results. Tell us what you have gotten, 100%, Why do you think you are getting 100% in SVM, but you are not getting in J48? What could be wrong? So after that, we think of, okay, let's do feature selection. See, let's do feature selection. So in this feature selection, what was done? We actually described it earlier, but we want to see this is a practical manifestation of what we actually described that time. So the feature selection that is done here, that we did, what we made use of, is the correlation attribute evaluation tool in Weka was employed to the whole data set to rank the attribute based on their correlation to their target attribute in descending order. You see? So I say you can use Weka to do it. You can also use your Excel file to do it. What are we doing there? Basically, we are trying to see what are the features that are highly correlated. After doing that, then we use what we call recursive feature elimination procedure. A recursive feature elimination procedure was applied to divide the features in half in each iteration until the single feature is left. So what it means is this. Let me show you that particular portion that we saw it earlier. This is the attribute. This is the correlation of the attributes, each attribute to the target. So we are already in descending order, the highest on top. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. So you have 20 features. So we have used the 20 feature. We got 100% for SVM, but we are not getting yet 100% for the other one. So we want to try feature selection. Because one of the advantages of feature selection is not just to get accurate result, but to reduce the computational complexity. If I can get the same result using 10 features, why should I use 20 features? Because in preparing questionnaire, asking 10 questions from people is easier for them to respond than asking 20 questions. So one of the advantages of feature selection is to actually make life easy for people that will respond to your questionnaire. So it's not just about accuracy only. Of course, sometimes we gain advantage of accuracy. But when you are getting 100% already without feature selection, somebody asked me, doctor, why do I need feature selection? I said, you need feature selection to reduce the number of features, even if you already got excellent result. However, you don't compromise your excellent result because of feature selection. But if we can still get the same excellent result, why after feature selection? Why not? So this is what we actually employ here. We actually demonstrated it by what we call the recursive feature elimination. And what is recursive feature elimination? We selected, you divide, every time you divide it by 2, V divided by 2, the number of features divided by 2, which is 20. 20 features divided by 2, that's going to be 10. So I'm going to select the best 10. The best 10 features will be selected. 1, 2, 3, up to 10 that are having the highest number. And I'm going to run an experiment with those 10 features. The next stage, I will divide 10 by 2, that's going to be 5. Then I count the best 5 from top. 1, 2, 3, 4, 5. That is 5 features. I'll run an experiment using 5 features. Then I'll divide 5 by 2, that is 2.5. Of course, you are going to get 3, you round it up. You select the best 3 features, 1, 2, 3. You run the experiment. 3 divided by 2 again, you're going to have 1.5, which is 2. Run it with the best 2. 2 divided by 2, then you're going to have 1 feature. Then you're going to run it with only 1 feature. And you report your result as we have done. This is what we call recursive feature elimination. You are reducing the number of features by half recursively. You can see here, we use 20 features, we got this result. We use 10 features, we got this result. We use 5, we use 3. You can see something unique is here. If you can see my screen clearly, here SVM has been getting 100% consistently, 20 feature 100%, 100%. However, J48 improved a little bit. From 95.79 when we used 20, it became 95.96 when we used 10 features. So we are going to go for the best is to use 10 features, because the moment we reduced the number of features to 5, the 2 of them started going down. You can see even support vector machine started going down. It means With 5 features or less, we are not able to get the maximum result. So we stick with 10 features that give us maximum result with lesser number of features. This is what we call feature selection. So we can also try to demonstrate it for us in Weka. How do we do it in Weka? You have 2 ways. After you have identified those features, you either prepare a new CSV file and put only those features there. However, in the runtime, maybe it could take your time. So, but while you are in Weka, you just try to remove those features appropriately. See, remember we demonstrated it here. Here, this is the Weka. The data is already loaded there. You go to pre-process. You can see your feature. Any feature I don't want, I just select it. Just select those features. Maybe you want to remove the last 10 that are not good. Just select them and then click remove here. Remove. Once you remove it, then you run your experiment. It's going to run the experiment without those ones you have removed. You see, after your experiment, if you like, you can bring them back. You just say undo. You get back your full data set. This is a simple way you can do it directly in Weka, or you can create a separate Excel file depending on the situation that arises. So this is how the feature selections could be done. So having done this feature selection, you can see here we have 100, 100, and host of others. And then there we move on to this result and discussion fully now follow, because you have done feature selection. We are able, with feature selection, we're able to increase the performance of J48. But most important for me is the number of features we are reducing. Imagine you produce, you have a questionnaire for people. I have 10 questions for patient to answer. You have 20. Which one do you think the patient will be willing to answer? For definitely, a patient will be willing to answer 10 questions quickly rather than answering 20 questions, because that looks so weird, so many. If I can even get 5 questions to solve the same problem, why not? However, the accuracy here is unacceptable. It goes from 100 to 95 when I try 5 features, so I have to ignore that. So I will declare that the best is to go for 10 features where we got the best possible average result for the 2 methods. So we discuss our result. We tell us the implication of what we have done and what is the implication, what is the advantages, what does it hold, and also of other issue that we can actually incorporate. So we discuss it as much as possible. Like I told you, these 2 experiments, one for 3 classes, one for 2 classes. So we put up the results. Another thing that we mentioned earlier is that you need to pay attention to is the confusion matrix. Let us see the confusion matrix. You see, which is how do you apply confusion matrix in your work? Okay, this one is doing fine. What is the false positive? What is the false negative? What's the true positive? What's the false positive? All those ones need to be explained to people in your discussion of result. Because if you are doing fine and if mistake from medical application, if they are more of false negative, it is a little bit dangerous, because you are asking people who are sick, you are saying they are not sick. So they go and think they are not sick and they will have complication. So that's why false negative is very dangerous in medical. It's better to have false positive so that you can go and repeat the experiment. You are telling somebody that is sick, meanwhile he's not sick. But that is a good mistake. We don't want any mistake. Every mistake is bad, but some are worse than the other. So you say somebody is not sick, you say he's sick, you go to clinic for further checking, and they can come back and they will think, oh, you are not sick. Sorry, it was a mistake but from our AI system. This is better than asking somebody who is sick to go home and they will have complication because of the mistake. So false negative is a big issue. We already explained this concept in some of our previous videos, the difference between false negative and false positive and the implication for different areas of application. Now, this is also done here. We have the false negative, false positive, and the rate. So based on what we have discussed, we also have other curves like the ROC curve, which is another way of showing further your result of classification. And of course, you don't forget to have a very interesting and fantastic conclusion and recommendation. Usually you should have conclusion, you conclude your work, what has been done. So did you achieve your objective? What can we really make out of what has been done so far? And what are the implications of the result? And of course, while doing the experiments, you will have passed through a lot of information. You get to know a lot of things that time does not permit you to do. You want to do something, time does not permit you. We call them fence out in your research. Fence in, fence out. Fence in means those things you included in your work. Fence out those things that are relevant, but maybe because of time or some limitation, you cannot include them. You need to put them in your recommendation. That's why I always like conclusion and recommendation, not only conclusion. Put some recommendation there so that future researchers can read your paper. They can have an idea of what to do. Because some of your recommendations are things you want people to do in future, maybe to make the work better or to look in some other direction. Put it there, let other people benefit from your idea. Of course, I've seen researchers who say, if you put your future work there, some people will do it before you do it. To me, I say that is fine. If people benefit from my idea recommended in my paper, I think that is a plus. So we have so many other things to look about and do. That means some people also, they want to hide their own future recommendation because I don't want someone to do it. Idea will always come. Always try to benefit people. Don't care if they do it, that's fine. You always get better ideas later to do, and you also recommend for people to do. This is my own personal way of writing, my conclusion and recommendation. I will put some of the things I think needs to be done, some of nice area to be looked into as new research or future research possibilities. People read the paper, if they benefit from it, that's going to be a kind of benefit for someone. And if no one does it until we have time to come back again and do it, that will be fine. Because sometimes how many recommendations we put out there that we never have the time to even do it. So why not put it there and benefit people, maybe young researchers who are looking for ideas. When you see very good paper, just go to their recommendations or their conclusions. Some of them will tell you the next thing that should be done in this area, which is always good for young researchers to learn, oh, what are the gaps? What can I try to investigate? So some good paper, they always try to put this kind of thing there. So I think that concluded our demonstration or discussion on anxiety paper, COVID-19 anxiety predictive solution using machine learning. And that's what we are going to have for today. So thank you very much all for listening. So we are going to listen to a few questions or comments if there is any. Once again, thank you for the time, and I wish you all the best.